All right. Hello, anyone who's watching. I'm Dan Finlay, joined here by Julien Genestoux
Hi, yeah, good pronunciation.
of Unlock Protocol. And we're going to be talking a little bit about Unlock Protocol and the delegatable framework that I just released. And Julien was interested in, does this do anything for Unlock Protocol? And I'm curious too. And it's been a while since I read the Unlock Protocol contracts, and so we're gonna kind of look at, we maybe look at some real code. We'll look at how Unlock works. Unlock's a protocol for using NFTs to paywall content, or not necessarily paywall, just
Memberships, yeah, basically any
control
kind of
membership.
membership. Yeah, so it could be in the paywall content, but it could be also membership to a DAO that we're seeing more and more people using Unlock for, or tickets to a conference. It's a membership to the conference. It's kind of a weird way to say this, or even SaaS product, like a product that instead of there's a free version and the paid version is accessible if you have an NFT in your wallet.
Cool. Yeah. And you were just telling me how you have like some customers, like let's say you've got a magazine publisher that wants to onboard users more easily. Maybe they want to grant access. Maybe they want to make it an NFT, but maybe they don't want their users to have a crypto wallet, and they don't want their users to have to pay gas.
Exactly.
And those are a couple of things that I think the delegatable framework is good for.
Absolutely.
So which way would you like to start? I think we should probably both have like a little share. Do you want to start by talking about just the basics of Unlock?
Yeah, and maybe I can try to do a very quick demo if you give me 1 second. Yeah, I mean, it's completely improvised here, but let's actually try that. I'm going to share my screen in a second, just making sure it's all configured the right way, and I'm not going to disclose any massive secret here, like my private key.
Yeah, that's always the fun thing about screen sharing.
This is actually a website that I like very much. You can go there, split.online/xi, and this is a website that a musician down in Mexico created. And what they've done is they put the music on the website, and they say, if you're not a member, you can't really listen to the whole song. You can only listen to the first 30 seconds. And I have it in my ears through my headphones, but people can do that at home. And what they've done is deployed a smart contract using the Unlock protocol on the Gnosis chain in that scenario. And then they also use our front-end snippet, but they could have implemented their own version of this, like the guys at MyCrypto did, for example. And so if I click on this little button here, you see that I'm prompted with a checkout UI that allows me as a crypto user, actually, let me disconnect my wallet, as a crypto user or as an Unlock account, we'll talk about this, to access this content. So I'm going to click this button, connect my crypto wallet. I'm using MetaMask here. Since I already connected, MetaMask is not prompting again, which makes sense. And now the only thing that I have left to do is click on the wallet button. MetaMask is going to prompt this time, say, hey, do you want to spend one? So it's XI on the Gnosis chain plus 0.000 something of gas. I'm just going to hit confirm here. And then right away, we do what we call optimistic unlocking, which is optional, but we look at how likely the transaction is to go through. If it's good enough, then we'll just unlock. And now you can see this fake CD starts to rotate, and I can listen to 4 minutes worth of music. So pretty basic. And obviously the fun part is, like, I did receive an NFT as part of this. So we have built a keychain, which is a UI for people to see all of their NFT memberships. And yeah, this is the one that I got here. It's called void2.mp3, and it's on the Gnosis chain. You can actually go see the contract. You can see on Block Explorer, which is Block Scout there. And what I can do here, for example, is cancel it. So if I hit cancel, I'm going to confirm this. And then hopefully, if Gnosis mines quickly tonight, which I think might be the case, I'll get the refund immediately. You can see the amount very soon go back to probably something like 24, 25 XDAI. And I say very soon. Little cue music here. Hopefully. Yeah. Ah, damn it. I mean, I did it earlier. It took like 2 seconds, which is perfect. Okay, just did it. Cool. So I have my money back now, and let's give it a couple more seconds, because I think we're still waiting for at least 1 or 2 transaction confirmation. But I can refresh that page now. And the cool part is, yeah, now I don't have the NFT in my wallet anymore, so I don't see the CD and I don't have the thing. And I could go back and do the same dance again, purchasing again and having another membership, but you get the idea. Cool.
I don't want to do a full security audit or anything, but is the website Zplit just kind of trusting your wallet for what account you are?
Yes and no. So yes, but at the same time, yes. So in that scenario, yes. In our checkout flow, we have a way to ask the user to sign something, and then the website could actually get the signature as well as the signed message and recover the address, and then query the RPC endpoint to get all of that from the get-go. our front end basically, since they use our front end to say, hey, if you don't require the signature, you can trust us. Otherwise, just require the signature and you don't have to trust us at all.
Cool. Sounds good. So then what does the contract look like? I mean, it sounds like it's a pretty straightforward NFT type contract, right?
Yes, with a bunch of little fun things in it. So actually, I'm not a huge fan of Block Scout as Explorer, so let's actually switch to Rickaby because I feel like it's easier to read stuff on Etherscan, but obviously it works well here. So let's actually go look at this. It's obviously, so first of all, actually, that's a good one. This one is one that I deployed yesterday to do a demo. What's cool about the contract is like it's upgradable, but not by us, Unlock. It's upgradable by the person who deployed it, by the owner of it. For this, it actually is a proxy, so I'm going to have to verify this because Etherscan requires me to do this, but it takes 2 seconds. And then actually, let's look at this. So yeah, it's pretty much like, it's an ERC 721 compatible contract. It has pretty much all of the functions that you can assume from one of these. One maybe of the big differences is that by default, when I deploy the smart contract, I picked a duration. So each membership is valid for, a second, a day, a month, a year, 1,000 years, anything. And I pick this as a creator. I set the price for these memberships. So in either the native currency or any ERC20 on the chain, I set a bunch of other characteristics like, cancellation term, transfer fees, all of these things that could be happening here. But indeed, it's an ERC 721 plus, I'd say.
Well, what's the role do? I see you've got a role system.
Yeah, so we have basically, so the concept of the lock manager is the person who deploys the smart contract. The idea of having a lock manager means that I can have multiple lock managers. So I can say, hey, okay, this is a contract that I want Dan to co-manage with me. I'm going to grant you the role, the lock manager role. So I'm still managing it. I'm still kind of a root user on it, but you're also a root user on it. I can renounce my role. You can renounce yours. At that point, it's completely permissionless. Like nobody can change it. We also have the concept of a key grantor, which is an address that you trust to airdrop NFTs to people that have paid otherwise. We actually use that for credit card. And maybe I should mention, we have a way for people to pay with credit card on their smart contracts, which is pretty cool. And that's leveraging that key grantor role. We also have the role of a key manager. So each single NFT, we call them a key. Okay, I should clarify this. The smart contract is a lock and the NFT is a key. Not a cryptographic key. It's a key because it's a lock, right?
Cool.
One of the things that we've done on the contract as well is decoupling ownership of the NFT from the transfer rights. And so that allows us to do really cool things. Like I can lend an NFT to you, which means that you become the owner of the NFT, but I keep for myself the transfer rights, which means that at any point I can take it back from your wallet. Okay.
Which role is that?
That's the key manager. So for a single key, it can have a manager that is different from the owner.
Cool. And that would let somebody like borrow the NFT. They could listen to the song over there on Zplit.
Yep, cool. Exactly right. So I can either transfer the whole NFT to you and then you listen to it and it's yours, but I have no way to get it back. But I can also say, hey, okay, Dan, I'm going to lend it to you for a couple hours. You use it. And then when I want you to take it back, I can actually do this because you don't have the transfer right. I do.
Cool. Yeah, that all makes sense. Also, let me just, a distinction between key grantor and key manager. Yeah. The key grantor dictates who can issue the NFT, and then the key manager is who can manage your individual NFT.
Yes, exactly. Right.
Okay.
Yes.
Cool. Okay, I think I got the basics at least, and enough to I think start a conversation. And it's funny how much this I think your use case is almost uniquely has a strange amount of overlap with the delegatable framework. That's I think that there are chunks of code here that you could spare yourself of using this framework.
I'd love that. Yes.
Okay. So let me show you what I got. I'm going to share a desktop also. Also, hope I don't show anything. Okay, so here's just, I'm keeping my notes as we go. And okay, so the delegatable framework is basically, well, it's a subclass. So I almost want to just start with the like the README. The README doesn't look good at all, does it? Where's the prep? I'm opening it in. Here we go. Yeah. So it's a basic subclass. You basically make your contract delegatable, and then you're going to inherit a bunch of characteristics. You also have to make this, you have to include a message sender function, and anytime you would check message.sender, you call message sender instead. Okay. And so this is like one magic function that you have to include. Okay. But that's what it looks like to integrate.
Oh, so
And
it's
what
pretty simple. Okay. And the
well,
idea of the
integrating
message,
it. Yeah,
the idea of the message sender function, I assume, and I see the L statement, is that it does something special in some
mhm,
cases, or just calls the regular message sender.
that's right.
Okay.
Yeah,
Okay.
so it has a way that it'll call the regular message sender. What it's actually doing is it's doing this crazy thing, which is it's splitting the, if there is an extra 32 bytes at the end of the call data, it will use that as the sender. And but only if it's sent from the same contract. So what this allows is this allows internal method calls to emulate other senders.
I see what you mean. Okay. So basically the contract can call its own functions, but in that scenario, it doesn't show itself as the sender. It
Yeah.
uses whatever is the last bytes of the call data.
Yeah, and specifically,
Very
there's
cool.
really one function that ever uses that. And I probably shouldn't make you read the real code, but this is what it is. This is what the delegatable function is. It's mostly for the invoke function.
Okay.
So what invoke lets you do is this gets added to your contract, and it allows you to submit these arrays of invocations. These are kind of like transactions. They're actually like batches of transactions,
Okay.
and they will and it'll go through each of those signed invocations. And for each one, it's going to verify that it's signed by the appropriate signer.
Okay.
It's going to enforce its own replay protection, and then it's going to invoke it.
Okay.
So that's pretty straightforward. However, the invoke itself with that invocations batch, there's a fun little thing here. So the invocation signer and the is not necessarily the message sender that's going to happen, because the whole concept of delegatable is it lets you delegate who can do something on your behalf.
I see. Okay. So let me try to rephrase it. It is kind of a meta transaction in some way, where basically someone is able to sign transactions,
Yeah,
but basically allow someone else to execute them. So which is why it's actually very similar to meta transaction in that scenario. And the way it works is by adding the executor, I guess, as the at the end of the call data. Is that right?
yeah, that's how it ultimately works. And so yeah, it's actually very much, it basically is a form of meta transaction.
Okay.
The one difference is that a meta transaction would say, I can sign transactions for myself, and then this contract will process them as if they're from me.
Yeah.
But what I can do here is I'll hop to the types, is I can sign these messages. I can sign a delegation message. So here's the type of a delegation message.
Okay.
So I will assign an address as a delegate.
Yeah.
I will provide some authority, which will normally be 0 if it's just from me. And then I can add caveats. So
okay,
I can say,
let's go step by step. So delegate is the person who's going to execute the transaction as me.
Yeah. So if I were to hop to your example, when you have the key manager, you're choosing someone else that you want to be able to use your NFT for a little while.
Yes, exactly right.
Now here you could sign an off-chain message for a delegation, and you could assign a delegate.
Okay.
And you could probably do the same thing. Now the difference is that your key manager has some limited things they're allowed to do, right? They can't just do anything, or they could transfer away your NFT, right?
So it's actually the opposite. The key manager is me, and then you would become the regular owner. So basically, when I lend a key, I set myself as the true owner, exactly. And then you become the owner in the ERC 721 sense. In that scenario. So it's like key manager is basically a higher order role, if you want, as the owner versus the owner, which is just the owner when it comes to balance of or owner of functions.
Okay. So here, okay. So this doesn't like overlap, but it like lets you do some kind of different things. So we'll try to pick at what you might use it for. So you could delegate someone, and then the caveats are these.
Let me actually tell you one other thing where that could be really useful. So one thing that I told you is, like, remember the credit card flow? So when, say you have your own lock, your own membership contract, and you want to enable people to purchase credit cards. What happens is, like, technically you would allow us, but actually a third party as well, to be a key grantor, so to grant keys, and then you give us access to your Stripe account using Stripe Connect, so we can charge cards on your behalf. So basically what happens, like, we charge a card and then we buy the key for a user. basically, and then we give it to them. We when I say we buy, we grant it because the user has paid with credit card, and say we grant it for free. This is useful for people who want to pay with card, but this is even more useful for, people who pay with cards we don't have a wallet. So for now, they have what we call an unlock account. We create a public-private key pair for them. We just discard the private key in some way, but this way we have an identity for them. We know like there's 0x12345. With what you're describing, and so now what they have is like they have the NFT, but they really can't do anything with it. They can't sell it, obviously, because they're actually not the manager, but they can't even transfer it, or they can't do much with it. But what your example here, they could actually do a lot of things because these users don't have gas, obviously, because they don't have a wallet. They just have an identity on chain. And so I guess with a system like yours, we could have a system where these users could still kind of, allow us to do certain things with their key because they would allow put us as delegates in that scenario. Does that make sense?
Yeah, that is one way. And then it also could be useful on the lock. So imagine,
Yes.
for example, if the magazine publisher of a lock,
Yes.
they want you to be able to issue NFTs,
Yep.
but maybe they want you to only limit so many.
That's
right?
actually a good point. Yeah.
Okay, so they would delegate you the authority to mint.
Okay.
And the problem is a plain delegation message lets you do anything the calling person can do.
Yeah.
That's too much.
Yeah.
And that's what the caveats array does.
see.
The caveats are extra restrictions. Each caveat is a contract at an address that will receive some terms and a proposed transaction. And they get to decide if they can reject it if they'd like.
I see. So that basically they would decode the code data and say, okay, cool, this function you're allowed to, or this function you're not allowed to.
Yeah. So like, for example, an allowed methods enforcer, this would be a type of caveat enforcer. Okay. Where it gets the terms, it gets a proposed transaction, and then it gets the hash of the delegation that it was from. Yeah. And so it knows, so first it strips off the first 4 bytes to know what method is being called. Okay. And then so its terms are going to be just a list of 4 bytes. So it's going to iterate through. So for each 4 bytes of the terms, okay, it's going to check if it's one of those, then it's okay. Otherwise, it's not okay.
I see. And the idea is like here, when you deploy a caveat enforcer, you can have multiple things. So you can say, okay, you can only call that function, that signature 7 times. And then basically the caveat enforcer would keep track of a counter in a scenario, and the 7 times this gets executed, it would say, nope, no more. You can't do that anymore. Yeah.
Okay. So here's a limited calls enforcer. So I see. So it keeps a mapping of call counts, just like you described. So every time it counts it down, and then it counts it down, and then it says it'll throw an error if you exceed it. And so we can make any number of these. So I've represented an ERC20 allowance as a caveat. And
interesting. So that's actually a much better system than the approval
or the permit method.
Yeah, the permit method.
It's pretty much equivalent to the permit method. Oh, except that a cool thing that I haven't even quite gotten to yet, but see this field where a delegation can have an authority?
Yeah, I wasn't sure what it was.
That can be the hash of a previous delegation. So these can chain together off while being off chain.
Tell me more about that, because what is, before we talk about the chain, tell me what is authority for, I guess, in that scenario?
Yeah, so this is basically, this makes it a linked list. So when I'm submitting, I'm going to hop back to our invoke function. So yeah, when it calls invoke, it's going for each transaction, for each invocation in the batch. Yeah. It's going to be going through the authority array. The authority array is the array of delegations. And so here is the signed delegation is for each authority. It's going to be going through those. And then each time it's going to be the next one in the chain. And then somewhere in here, it's checking that the delegation hash. Yeah, so it gets the hash of the delegation, and then and then the next hash, right? So then it assigns the delegation hash to the auth hash, and then the auth hash, where is it checking? Oh, wait, we sign it there, and then somewhere in here, it's making sure they chain together. So basically, if I delegate to you and then you delegate to someone else, they can now call on my behalf. You can have these delegations. Each one can refer to the previous one.
Isn't that risky? Like if I get compromised in the middle, then it means that
So anything that I've delegated to you, if you get compromised, that up to that much authority could be compromised. Yeah.
I see. Okay.
But so if I've written my caveats good, then if I have some good caveats and I've made sure, for example, if you're an NFT minting delegate, and I say you can mint up to 100 NFTs and you get compromised, or you can use 100. It's like a circuit breaker. So once you go up to that limit, that's how compromised. But it gives us this tool for delegating kind of limited authority. So instead of having a list of roles, we can kind of dynamically make as many delegations with as many specific caveats as we want.
Okay, yeah, that's interesting. Okay, that's really cool. Okay, do you want to show me some examples of how? I mean, you were
sure. So the most so here's the contract that I use for the tests. So it's what is it? It's got a purpose string.
Okay.
And then it's got a set purpose function, and it just updates the function.
Okay.
And then later you'll see MobiMask uses something like this. It has a Fisher registry where you have an identifier to whether it's a Fisher, and you can claim, and it's only owner. So only the owners can call that. But if the owner delegates, then these would work for that. So let me go over to a test then. Is this the good one? Let's see if this is the test that's relevant. A membership API. Oh yeah. So here I'm using a membership API. So I made a kind of convenience library. I'm calling the membership API. So like any EIP 712 or signature. 721, 712.
Yeah.
So like any assigned type data signature, we need this contract info. So it has the chain ID, the address, and the name. So that's all fine. Oh, this is Fisher registry. It's not the I'm actually a little, this must be the wrong test. Hold on one sec. Let me find the right test for this. No, it does look kind of right. Or it's unit test. Okay, let's read over this one for right now. We'll see if it's the wrong one. Okay, so we've got that. So there's Alice can create a membership from the contract info. So this, if now this membership represents an object, she can now call functions that are just per her. Well, this is not enough to do much because it doesn't have a key. Oh, right. And this throws an error because she needs a key. Okay. So now we make a membership and we give it a private key. Okay. And then that works. Okay.
What's this was not here? I mean, I'm a bit confused. What's a membership?
Oh yeah. Sorry. This is not the right test to be showing you. This is I see where I was. Okay. My test. This will be better. And let me see. Which one's this? Generate utility. Okay. So this one's a little bit lower level, but it'll be better for demonstrating, I think.
Okay.
Okay, so we can set purpose by owner, changes the purpose.
Yeah.
So like normal, you can set the purpose, and then you can, like you would expect, the owner can change it.
Yeah.
And other owners, other accounts can't.
Yeah.
Okay, now here's a basic delegation. So we have a target string, and then we have the contract info. And now here's what a delegation looks like, right? So the owner wants to delegate to address 1.
Yeah.
And if they're delegating their own authority, then authority is just 0. It's a nothing. And there's with no caveats
before. And they say
anyone, and no caveats. So this is the simplest full delegation.
So technically that means whoever is going to get the delegate here will do anything on the contract.
Yeah, they can do anything. This is a silly delegation. They would even be the owner of the contract. They could steal the ownership.
What's interesting, they're actually not the owner, right? They're just delegate. So it means that you can have technically 2 owners in that scenario.
Yeah. But they could take the ownership because this delegation.
Yeah, they could change ownership. That's a good point.
Yeah.
But could I mean, assuming this would be prevented, does that mean that they can execute things as the owner? They're not the owner, but they can execute things as the owner in that scenario.
Yeah, they can execute anything as the owner.
Okay, so every time you have a modifier only owner, for example, arguably this would check the message sender that you overwrite, I guess, in that message sender.
Yeah, something that's cool is if you're using Open Zeppelin, then they're already using the underscore message sender internally.
Things. Okay,
so when you overwrite this, all Open Zeppelin libraries will.
I was going to say, how does that work with libraries that you include that already have message sender but don't override it? Okay.
Yeah. So message they have one. It's just message sender, but internally it just uses message.sender. But it's like it's a really good practice because it allows you to override
it allows for like a lot of. Actually, that's a good point. Like any of the core message dot something or even like block dot or things, it's almost like a good practice when you write Solidity code to have them as wrapped inside a function that does the equivalent. Okay, interesting. That's something that I learned.
Yeah, cool. It's a nice thing. I don't know how often people use that feature, but it's a really nice one for this use case.
Yeah.
Cool. So then once we've got that, I make this utility that it helps with a signature.
Yeah.
And so then I sign the delegation. So the delegation and the private key, and I get this signed delegation.
Okay.
And then once you have a signed delegation, you can now we can now make a transaction. So first we're going to say, what is it that we'd like to do? Ethers lets us do this thing called populate transaction.
Yes,
so we're creating the transaction data just so we can get the TX data. So then this is what an invocation looks like. It's a little big, partly because we have our own replay protection in the system, right? It's a meta transaction. I didn't want to just use nonces. I used another thing from a meta transaction hackathon. There's queues, and so you can just you can randomize your queue every time and just always use nonce one, and basically you'll have non-blocking.
So the nonce, if I'm correct, is basically the contract will keep track of the nonce per address, and then we'll make sure that a single transaction gets only executed once because it's nonce one is signed once. Right. What is the queue for?
The queue gives you any number of nonces. So you can have it's like more lanes on the freeway, so the transactions can go around each other.
I see. Okay, interesting.
Yeah, so it's just a way to let you do meta transactions. You still get replay protection, but you don't have to think as hard about. And also, it's actually very important for some things, because sometimes you might want to sign an invocation that someone submits lazily. Like you might want to say,
you don't know where they're going to submit, and you don't want to block everybody else because waiting for that guy. Okay.
You don't want to block. Yeah. Okay. So a lot of this system is designed so that you can do stuff whenever you want. So so in the magazine subscription example, if you pay with your credit card for my magazine access, I might sign you a delegation to redeem the NFT, right? And I might pair it with a key. So I send you a key and a delegation message. Now you haven't had to pay any gas or anything, but you have the right to withdraw the NFT. And that's partly possible. Well, actually, the replay protection isn't necessary because I gave you a delegation, but I could even give you an invocation from my own account. Although, I guess I could block it with my announce. So it doesn't solve that. Okay. So anyways, we'll move on from the replay protection.
We'll find some.
It's a fun little feature. Okay. Yeah. Okay. And so then so then it has a batch of invocations. And so, there's a batch of batches kind of. So the authority is an array of the delegations. In this case, there's just one delegation. And then a transaction. It's very much like a normal Ethereum transaction. It's got a recipient, a gas limit, and then TX data. And then we sign that. So we create a typed message, we sign it, and now we've got a signed invocation, and then that's what we use in the invoke function. It's an array of signed invocations. So you see, there's actually a batch.
It's very similar to how Gnosis multisig works, or in the end, it's kind of like submitted. Okay,
right. And then we see that it was changed, and then the next step up is that the delegate can then delegate. So once you've got that delegation, rather than signing, we've now got the second person wants to make a delegation. They want to delegate to address 2, and their authority is the hash of the first delegation. So we're hashing the struct of that first delegation.
Okay.
And so then the final authority is now signed delegation 1 and signed delegation
2. Okay. And the contract will verify that both chains basically, that things are validated. Okay.
That's right. And both of these have no caveats. And so they're very simple. And then and they're able to invoke, and then they've updated the purpose. And then
it's interesting because even the first delegate doesn't even have to do an on-chain thing. They can delegate off-chain to a second person, and then there's only one transaction on-chain. Okay,
that's right.
Interesting. Yes. Yeah, I like that. Okay.
Yeah. That's one of the coolest parts. And then I've got a test that demonstrates the allow list. So so in this case, we have a caveat now, and so here's the allow list enforcer's address, and the terms are just the 4 bytes of the method signature. And so it allows, and then the next one says it disallows a different method. So the caveats are working. I've got unit tests on the other caveats, but that's the basic use case. And then I can show you another more concrete use case. So I have a MobiMask here. So this is a kind of working application that uses the framework, and it uses let me see, have I got its test handy? I'll go to its hard hat and its tests. So it's got its tests are based on the same ones, but then I use this slightly different API. Oh no, generate util. Oh, okay, it's very, very similar. Okay, and so here now it's claiming if it's a Fisher. One thing that's different in this one is that we have we should have a base caveat. Oh, wait, hold on. Oh yeah, here we go. So one thing that I've done, and I kind of recommend this as a standard, is I make the contract itself a caveat enforcer. So with no terms, there is a default set of caveats. The reason I ended up doing that, and this is kind of an aside, but I'll just show you what it looks like. We have the Fisher registry, and I made it it's not just delegatable, it is revocable, ownable, delegatable. And if we go to that, oh wait, where's a revocable, ownable, delegatable? Okay, so it's got, so it has enforced caveat. So it is itself delegatable and ownable, but it's also a caveat enforcer with an enforced caveat. So it has a custom enforced caveat. And this is partly because it saves the gas cost of calling an external caveat if there's like a very common caveat. So for example, one thing I realized is I wanted pretty much every delegation to be revocable here.
Okay.
So I keep a revocation mapping. And so anytime that you refer to the own contract with a blank caveat, you can revoke it.
I see.
Yeah, and I made it so revocation is not built into the system because I want you to be able to make credible commitments. If you give someone a delegation that says you can mint an NFT,
you don't want this to be revocable, because otherwise you just say, hey, you can this revoked, and then haha. Yeah.
Exactly. So these can be credible commitments, but you can make them so they are revocable. And then also I wanted to make sure that the signature was not either of the owner methods. So there's transfer ownership and renounce ownership. I want to make sure that, as long as so basically if the root person delegates with a caveat to this contract,
they can still get back control of the contract.
That's right.
If everything goes wrong.
And nobody later on is able to call either of these functions. So later people don't have to include any caveats. They won't be able to revoke, but at least no one will be able to accidentally transfer ownership. So that's just,
I see you hard-coded here the signatures. Wouldn't there be a way at the constructor time to just say, okay, cool, that's the function that are protected in that scenario? I don't know if that's possible.
I don't know. Honestly, I don't write a lot of Solidity. So for me,
I thought you wrote this. Okay.
No, I wrote this, but I don't write a lot of Solidity. So this is not like audited. It's probably not production ready yet. But it's it's kind of a conversation starter for now.
But I like the pattern. I honestly like the pattern. I'm actually, it's funny because as you mentioned this, I'm thinking a lot about these what did they used to call them? The Argent like thing, contract.
Contract accounts.
The contract accounts, because I do think that there may be something like this where I have a private key in a system somewhere. I guess it would be interesting to no, actually maybe that's even better. Instead of having, actually I don't know, I'm thinking there's something along these lines where you can actually allow other people to do stuff with your smart contract instead of having it being on chain. So one of the Argent or all of these smart contract wallets, basically Gnosis is the same, is basically the idea that there's multiple addresses that can control the smart contract wallet. So you can say, okay, my friend Dan is going to recover if I lose my private key. Dan is going to be able to get me back in my contract. And maybe there's a level of things that only I can do if I have two confirmation from my phone and from my desktop. I wonder if this can be used in that context here without actually deploying code, which would make it really, really powerful.
Yeah. So there has to be at least a first contract that's on chain, right? That has the delegatable pattern. But let's say you had a first account, or actually even if a token was just delegatable, right?
Yeah.
Now everybody who has that token has all the benefits of it. So you might not have a contract account, but you're able to sign messages that give other people allowances. You can sign a limited allowance to your mobile device. You can sign a different allowance. You could sign a streaming payment to somebody, all with no transactions, right? And then you could also assign, and you could assign all of those with like a revocability that could be called, and that you could pre-generate revocation messages, and you could send those to your friends. You could send revocation messages to a bank or something, so that if they ever see something suspicious, they could cut off any one of your devices. and then you could just regenerate the delegation messages whenever you felt safe again.
Yeah, I mean, yes, I absolutely. I mean, all of these things are. I mean, again, like I've got this thing about the meta. I mean, like losing your private keys, blah blah. It's a pain, and I wonder if there's a mechanism where you say, I'm basically delegating to myself to another temporary thing address of mine that I can use to do certain things. And I know it's kind of a low risk thing because it can only do certain things for a little while rather than do everything. But you're right. In the end, I mean, either all of the contract implemented or you have a smart contract wallet that actually is the thing that has the delegation logic in itself.
Yeah, and if you had your own smart contract wallet that was delegatable, and I think we could make this as like a Gnosis Safe add-on too. Gnosis Safe has modules.
Yeah.
So let's say we made this one of those and you added that to your Gnosis Safe. Then I think you would be able to do things like let's say you control your Gnosis Safe with
your hardware
cold wallets, with a hardware wallet and another cold wallet, and then you could delegate a hot wallet to your phone.
You MetaMask for a couple of days, and you know that it's going to be on me for a month, and then the end of the month I can. I know that it's...
you could have a time limit, a spending allowance, a streaming thing,
a number of transaction limit, like it's just 5 transactions.
Limited number of contracts it's allowed to interact with.
Exactly right. Like
certain functions it's allowed to call,
but cannot spend my ETH. Yeah, exactly. And so that actually would be very powerful in that scenario, I think. Because it creates these kind of disposable private. I mean, it allows you to kind of have disposable private keys that are limited in terms of what they can scope, what they can do. Well, except that there's still the gas issue.
Right. Yeah. Somebody has to pay for the gas. I have, so this thing doesn't really deal with the gas incentives. It says you don't have to be the one who pays the gas. You can pay the gas. I kind of have a little bit of hope that, somebody will either come up with another gas incentive on top of it, or a lot of the times when you're paying someone, they have the incentive to submit the payment. So,
yes, but you could even make it so that it's a delegate. Like you can spend some of my ETH. Like if it's my smart contract wallet, then a service would be the executor, and basically I delegate to them the right to spend maybe not ETH like USDC on that thing. And
it would have to be because ETH. I think it would have to be some kind of token. But I would love to see that implemented. That was one where I'm like, that's a tricky one to implement, but it's also really powerful if we could figure that out.
Because that creates like these real meta transactions that this time are, I mean, feels very customizable and completely flexible. I like that.
Another one that I haven't made, but I think could be interesting is charging for use. So you just gave the example of paying somebody back for calling a function, but then could you give someone a delegation that says like, hey, you can borrow my lock for 5 DAI per call or something. I'm not sure if that can be made as a caveat. I think if it can be made as a caveat, it's because the caveats only get initial terms and the proposed transaction. They would have to be tracking balance on the side. So I think you would have to do something like, it would be part of a batch where you send a token to it and then you tell it to check, and then it's like it approves, something like that. I think it's possible, but I haven't worked.
Or you would just check the balance, I guess. Well, but you don't know where it's coming from.
Right. I mean, the caveat could have its own balance, or it could track balances for people, and so it could have its own function for like you've pay for that person's transaction,
and then you can do this.
So I think there's a way.
This is an interesting pattern. So are you building this? I mean, you build this independently, but like, how are you going to get many contracts to use it? That's the big question, I guess.
So right now I'm just kind of sharing it around, and I'm kind of building proof of concept things. So like anti-phishing as a first use of proof of concept, I like it because if it doesn't work at all, or we find a security hole, we redeploy our phishing registry. It doesn't matter that much. But it lets us
you don't want money. You want information, not dollars or coins.
Information, not money is, I think, a good first use case. But then having conversations, having people experiment with it. There's another experiment Kames Gurity is doing where he's trying to make a registry for contract metadata.
Oh, okay.
It would be like method data, so to help make transactions more readable. That's another interesting use case. So I'm kind of just like having the conversations, and then I think.
But actually, let's talk about the phishing thing, because there's something I don't know. So you deploy that contract, and then you delegate to a bunch of people. Say, I'll trust you guys to do the reporting on this. Is that the idea?
Yeah. Today we have an anti-phishing list. We actually subscribe to multiple registries for anti-phishing, and we try to help warn people. I don't know if you've ever seen the big red screen of warning on MetaMask, but
I
like,
have seen it a couple times. Yeah,
very bad. You must have clicked a bad link.
I've clicked bad link, but I do click bad links. I mean,
Yeah,
almost like
yeah.
yeah, yeah,
Yeah, but but keeping that up to date is hard, and
yes.
a lot of it comes down to time sensitivity, because there's some new phishing link
Oh,
out there,
it's
and
like 2 days.
every
Yeah,
second that it's
yeah,
out there, usually
yeah.
I'm pretty sure what they do, they spin up a new site, and then they hit everything. They hit the Telegram, they
Oh yeah,
text
it
message
needs to be. It
people.
needs to be minutes. Yeah, and
Yeah, it
then
needs to
yeah,
be minutes, not hours. And so to be as quick as possible, we need as many people who are
reporting
as
these things.
empowered as
Yeah.
possible to flip the switch and set it off. But there can be abuse. So whatever mechanism we have, we need it to be very auditable. And so
Yeah.
here we get a system where as many people as possible get access to the switch,
Mhm.
but you get this chain of delegation with every single operation. And so if anyone misbehaves, we can revoke it, we
You
can
revoke the
fix.
whole tree basically in that scenario.
Yeah, and everyone they invited. Yeah.
No, that's actually a good use case of this. Trying to
Yeah.
think if there's other in that scenario.
Yeah. I mean, it's not perfect. Like, I think that one thing about it is that it means you've got this global registry, and now, you're like adjudicating everything. And I think you're kind of fighting an uphill battle a little bit. And
I mean,
also
it,
ideally
it's.
people can subscribe to their own registries and things like that. But it's a proof of concept,
I mean, it's yeah, it's it. I mean, it's. But I'm really trying to think about the delegates because I do think that one of the. I mean, I told you earlier, like one of the big unlocks, haha, of this is now thinking that then a bunch of the next Web3 users are not going to be people coming in for yield, or they don't have the $1,000 to spend on like some crazy NFTs and stuff like this, but they're just going to use that, and it's convenient to log in on website and then prove that you have the right credentials via an NFT. I think I do think that's actually one of the big thing that we're going to see more of.
yeah.
But these people, they don't have gas, so we'll have to find a solution, and yet they want to be able to do some things with their NFTs, and so yeah, there's maybe something there around delegating certain transactions that
Yeah.
you might want to do.
Yeah. So for example, let's say somebody paid with credit card, they got a delegation for an unlock NFT,
Yeah,
right? So it's a delegation that gives them the right to mint an NFT. It's not even an NFT, right?
yeah,
Now they could now go to a website, or let's say a Discord,
yeah,
that says you have to have this NFT.
yeah,
So you could either sign a message from an account that has that NFT right now,
yeah.
or what if you also let people sign a message that, here's a signed payload, you can submit it to that contract, and it will, there's kind of a question of what do you want them to prove? Do you want me to prove that I could move the NFT? Like, I will
I
prove
mean,
that
I just want to prove that it maps to your address on the smart contract, right? Like token
sure.
75 is yours, and I can verify that you're you because you've signed a message, and okay, cool, I know you have a valid NFT. It's not expired yet.
Yeah. So you could probably, if the NFT itself had you could have a function that just says like, I am the owner, and you could prove that you can sign a function that returns true, then it
I'll
doesn't
tell you
matter.
what, one thing actually
Yeah.
I think a lot, because so one thing that we have in the smart contract, so we have automatically recurring membership. So the one that I bought was for 1 day. It's using XDAI, but if it was using an ERC20, I could have approved 20 times the daily price, and now it would
Right.
have been renewed every day. I mean, it could have been renewed, and the way it works is like basically the contract has a function renew membership where you pass the token ID,
Right.
and then if the NFT is expired or nearly expired, anyone can call this. That will basically withdraw from the ERC20, the user's ERC20 balance,
Yeah.
extend the membership by the duration, and then there's actually a little kickback mechanism in the smart contract. One of the challenges, like right now, anyone can call this, and that's kind of on purpose. We want to make it so that it's completely open. Anyone can call this and get the callback, the little kickback of tokens to cover for the gas. The challenge, like there is a situation where multiple people can call it at the same time, and only when the transaction is going to go through, the rest are going to fail because that membership has already been renewed. So you can't renew it twice,
Right.
or you can't renew it until it's expired again. So right now, the answers that we find is like, okay, just use like one of these flash bots or things like this, where it doesn't submit a transaction if it's going to fail, which is fine. But I'd love to be able to actually have a system where it's like, no, I have a list of people that I approve to be renewers. And I think your mechanism here would work really well in that scenario. I guess you could delegate these to be, some people are approved to be renewers. I don't know what's the right word.
Sure.
Yeah.
Yeah, renewer. If another way that you could flip it is if the token itself was delegatable, and if there was a streaming caveat. So you could grant an allowance to your contract that says, at that rate, $5 a month or whatever. And so now you've got a delegation that gives you the right to withdraw at that rate.
Yeah.
And so now anyone could call the withdraw function. And if you called it 3 times in a row, well, you might actually get a couple, a way difference each time. You're just getting the latest balance, right?
Yeah.
They don't all have to fail. But the incentive would be to infrequently or only as frequently as you need to withdraw.
It's worth it. Yeah. Okay.
Yeah.
Interesting. And so the scheme that you describe here obviously works great for EOAs, but what about contract? Can contract delegate to other contracts?
So a contract account, if it was delegatable itself, could assign, could allow anything that can be done by a key to be delegatable.
Yeah.
And so if you're a multi-sig, you could have multi-signers who themselves delegate their right to sign. So I think that these actually combine and are composable. One way I've started to draw it is it's a little bit like a circuit diagram where a multi-sig is like an and a delegation is like an or. Delegation says either of these people can do it. And with the combination of those things, I think that you can build systems where you can have far more people with like varying degrees of authority and, and more hot devices that maybe can't exceed what you would want to
limits of what they can do.
Yeah. I think you could have stronger limits even on your multi-sig key holders.
Just don't do it to incomplete logic with delegation and multi-sig, or not end in XOR, and then we're screwed and we end up
you can imagine if you're like a DAO member and you're going to a conference, you might want to be able to vote on proposals, but you might not want to be able to give away your membership or something. Right? So you could sign yourself your hotkey. You could give yourself a hotkey.
Definitely.
Hot delegation says, you can vote, but you can't do other things.
I mean, that's definitely a thing that actually it would be useful on DAOs where, we have the delegation on the tokens, but I guess I don't know how that would work. But that's a good one for this, where you kind of delegate the right to vote to another address, and then assuming that the smart contract is done in a way that, only a single delegate per address can vote, might actually be an interesting way to do this.
Yeah, and it's
funny, so instead of delegating to one address, I can delegate to like 20 different addresses, and then whoever votes on my behalf, has voted on my behalf. It's fine, and I don't have to trust just one person to be voting on my behalf.
Yeah, and it's fun because one thing I was noticing is many contracts end up implementing delegation in their own different way. So ERC20 has the allowance, 721 has the allow, and then 1155 has the allow all and nothing else, which is like having an allowance without caveats.
Without caveat, which is crazy.
It is crazy. And then all the DAOs are having vote delegation.
I mean, the comp contract, I mean, the Bravo contract all have their own delegation, which it's another type of that. It's on chain, but it's another type of this.
But here it's like we can have a reusable pattern. Every contract can just be delegatable. It can be off chain. It can be chained. It can be customizable.
That's definitely a pattern. I like that. So it's cool. Awesome. So next step is for you to get some people to build this. I mean, we'd love to try to see if we can build this in our contracts. I think we'll have to think about what are the use cases that we're solving for and what are the things that we want to maybe replace ideally.
It's cool because it looks like you publish a lot of contracts, like you've made many unlock compatible contracts. So like if I were making a proof of concept with unlock, I would maybe look at that one where you're talking about the user who doesn't have a wallet, where you want to give them a right, but you don't want them to have a wallet. And then if they want to get a wallet later to claim the NFT, they can.
They could be able to do that.
But it lets them not necessarily do that.
Absolutely. Cool. All right, I need to go jump, take care of the kids.
Cool. This was great talking to you. Thanks so much for making the time.
Definitely, and then let's catch up in person soon.
Cool. Yeah, looking forward to it.
All right. Ciao. Bye-bye.
Bye.